So hi and welcome everybody. Welcome back to the course of wireless security. Here in this lecture, we will be following up from where we left off from the previous lecture related to wireless security. In the previous lecture, if you remember, we were discussing about the main threats and attacks and vulnerabilities that exist on different layers on the OSI model. So we discussed the attacks on the application layer, on the session, protocol, transport, and network and MAC layer and data link, and even at the physical layer. And we even talked about the main security requirements, and most importantly, the attacks that exist at the application layer. And we said that there are some attacks that are common for the wireless networks and wired networks, whereas there are attacks that are different and just unique for each network. Like especially for the wireless networks, we have the physical and MAC layer are completely different from the physical and MAC layers of the wired network. And therefore, there are unique differences between them, and the attacks that exist on the wireless network are different from the attacks that exist on the wired network at the MAC and physical layer. And if I remember correctly, we stopped at this slide. So in this slides, we are explaining and summarizing the security requirements and how these security requirements are being addressed and are being met in currently deployed wireless networks. So these requirements are listed as follows. We have first authentication. You need to make sure that your network has a very good authentication capability. The base station can authenticate the user can authenticate the base station or the access point in the case of Wi-Fi network. And we have the second requirement of confidentiality, where you need to make sure that the data is accessed only by the legitimate users, and all the external users who are not part of the network or who are not participating nodes in the secure communication, they should not be allowed to access the protected information. And integrity, which is designed to make sure that nobody can manipulate your transmitted data. If there is any manipulation in the data while it's being transmitted from the transmitter to the receiver, it can be detected. And in this case, we say that the data has been manipulated or it's not trustworthy data. And we mentioned about the availability, where you want to make sure that your network is available 100% of the time, if possible, by making sure that your network is robust against denial of service attacks that can exist at any of the OSI layers, including the application, the transport, the network, the MAC, the data link, the physical. And we said, like, the denial of service at the physical layer, give me an attack that causes denial of service at the physical layer. You will tell me that interference or jamming, wireless jamming. Give me an attack at the MAC layer that can cause denial of service. We have the flooding, MAC address flooding. Give me an attack at the transport layer that can cause denial of service. We have the TCP flooding, ping flooding. If you have noticed how to do this. Give me an attack that can cause denial of service at the application layer. This, we call it the brute force attack, that usually can be launched from multiple IPs in different locations, and just targets your application that's hosted on a certain X server. And usually you are hosting maybe your website on a shared hosting, and the host provider usually gives you limited resources in terms of CPU, memory, and server space. And then if someone requests, let's say there are your server can respond to just 1,000 requests, and let's say there are 10,000 requests coming simultaneously at the same time. Then what will happen? Your resources will be exhausted, and will run out very quickly, and therefore you will be under a denial of service attack, which means that when somebody else, when the 10,001 comes, which is your normal user, and it tries to log into your website will be unavailable for him or her, telling that the website is currently suspended, the resources are being consumed, and there are no more resources we can give you. And these attacks are critical. Many companies are suffering from them around the world. And there are many advanced solutions that are very costly and very expensive, but everybody wants to deploy them if they want to ever be secure on the internet. So different layers, different denial of service attacks, each layer has its own unique thing. But now, having discussed all these things in the previous lecture, and now what's then? How can we prevent these attacks? So the way that's being done right now on the wireless standards, on the wireless networks, is as follows. For authentication, to provide authentication, there are multiple methods that are being implemented at different layers of the OSI protocol model. For example, you have different approaches applied at different protocol layers, such as using MAC addresses to authenticate the receiver, the IP to authenticate the transmitter or the receiver, the SSL, the TLS, the WPA, which is wireless protocol access, which is kind of the password you enter when you want to connect to a certain public Wi-Fi network. So those are different authentication mechanisms. So WPA works at the MAC layer, TLS works at the transport layer, MAC address works at the MAC layer as well. You have also some algorithms, the encryption algorithms themselves that work at the application and transport layer. They also they are responsible for providing kind of authentication to the user. Digital signature is also a technique that's usually used to provide authentication. The authentication means that the transmitter that claims to be the one who has this data or the one who transmits this data is actually the legal, original, legit transmitter. You want to authenticate this. Nobody has spoofed him. Nobody has pretended to be that receiver. Nobody's trying to fake the original receiver. And this is the main job of the authentication procedure. Now, when you go to confidentiality, there are also multiple approaches that are used to ensure confidentiality in wireless networks. And these approaches include TLS. You have the TLS protocol that works at the transport layer. And this TLS, as you can see, it can be used for achieving confidentiality and as well as authentication. So one approach can be used to achieve more than one security requirement at the same time. So you have the point-to-point. You have the link encryption using point-to-point at the MAC layer, point-to-point protocol at the MAC layer, or you have also the secure IP, secure net, secure tunnel. Those are at the network layer. They're also responsible for providing confidentiality. Now, regarding integrity, you have the hash functions that are usually used in order to make sure that nobody has manipulated your data, or if there is any slight manipulation, you can discover it. This is to make sure that nobody has messed up with your data. For availability, I told you for availability there are different techniques. This is the most difficult one actually. First of all, you need to have enough resources, whether a server or base station or bandwidth or transmission or resources. When I say resources, I mean time, frequency, I mean CPU, I mean RAM, I mean SQL connections, I mean sessions, how many sessions are possible. for a certain server, or things like those resources, which are responsible for making sure that the communication is available and there is enough space for any new coming users who want to connect to the server or connect and talk to the base station or access point. And last one is privacy, which is usually guaranteed using VPN services, virtual private network services. You know, those softwares that they promote for them on the internet, and you pay for these softwares like monthly fees, $10 per month, $2, $3, based on the speed of the server and this. Those, they can provide privacy for you, and they can make sure that nobody can track you, nobody can check what you have visited on the internet, what you have browsed, or even they don't know your location, your IP, your PC. You will not be faced. You know, those websites that are usually blocked by your ISP, you will be able to bypass them when you have a VPN network. For example, let's say your Netflix is not available in your country and you want to access it from your country. The internet service provider is blocking it. So what can you do? You can just like install one of these VPNs on your computer, and the VPN will create a tunnel for you. This tunnel will be encrypted and it will not be seen by your ISP, and you will be able to log in and access to the website or anything that you want that's being blocked in your network or not allowed to access it. Also, people are really using it. In the old days, it was used for just a few people. Nowadays, almost many people are using these services. Now, as you can see, the most critical one among these security requirements is confidentiality. And confidentiality is basically guaranteed in current wireless networks using cryptography, end-to-end encryption. And the most common one that exists on wireless, even in wired and everywhere, is TLS, which is this is secure socket. SSL and TLS, I told you they are related to each other. TLS is the advanced version of SSL, and those are using encryption protocols and encryption methods. Now, what are these encryption methods? The most common ones that exist on the internet are the following. We have the RSA algorithm, which is really the most common one on the internet. You have the DSA, you have the ECC. ECC stands for elliptic curve cryptography. RSA stands for the names of the inventors of that encryption method. Hopefully some of you will be inventors for new encryption methods and the new security algorithms in this course by the end of this course, especially those that they work at the physical layer. And then we have the data standard. We have the DSA. Also, this is kind of encryption technique that depends on using symmetric keys between the transmitter and receiver. So now let's go and check those techniques, how they work and what we can do with them. So starting from the RSA algorithm. Now, before we talk in more detail about these things, let's make it simple for you so that you can understand all types of encryption algorithms that exist in wireless networks. So we have the first class of encryption methods. We call it symmetric approach. We have asymmetric encryption approach, and we have the hash function approach. Now, for the asymmetric approach, there is another name for it called the public key cryptography approach. And for the symmetric approach, we call it the secret key cryptography approach. And the hash, we call it one-way encryption, where you don't have any keys and it's easy to go from point A to P, means from a plain text to hash text, but it's very difficult to go in reverse. It's almost, as they claim in the current standard, it's almost infeasible. So now, how asymmetric encryption works? Basically, it depends on the use of public key and secret key. And think of those keys as like it was like one key, and this key split into two keys. One is called private key, and the other is called public key. Now, the public key is used to allow others to transmit their information to you. A private key is used to encrypt your data and send it to people, and those people can decrypt with their keys as well. And then the secure communication will be achieved and maintained successfully according to the protocol that's being considered and adopted in the communication standard. Now, one point that I want to emphasize here and make it very clear to you, that I want you to always remember that when you want to communicate with a wireless network, let's say I want to access a website on the internet. Let's go to a website, yes. Let's go to Wikipedia, for example. Okay, this is Wikipedia. Wikipedia.org. So here we are accessing this website. So what will happen here when if we click on this view site information? Now, how I access this website? I access this website remotely via wireless network. This wireless network is called Wi-Fi. Is that okay? This wireless network is called Wi-Fi. Everybody agrees with me on this. So this Wi-Fi network, let's say I want to check the security of the connection. Now I'm connected to this Wi-Fi network, and assume the authentication process is already done. I already entered the password for the WPA protocol, and now I'm authenticated to the network and authenticated to wireless access point, and the wireless access point can allow me to connect. And if you want, you can click on properties here, and you can go and check the SSID number of your wireless access point. You can check the protocol that you are using, which is Wi-Fi 802.11n. The security type. This security type is used for authentication purposes. This is the point where you need to enter the password to connect to the Wi-Fi network, and it's WPA2 personal. And the network band, the carrier frequency is 2.4 gigahertz. The network channel that I am connected on, there are 11 channels. I'm connected on 2. So if a hacker knows that I'm connected on 2, he can come and jam only 2 instead of jamming all the available channels and then waste more power than needed. And the link speed, this is the link speed. This is the IP version of my laptop, and this is the IP address of my laptop. So the IP address of this is the IP address. This is the IP address, and this is the DNS server that assigns I can take IPs within this range. And the manufacturer of the network card is Intel, and you have the driver version, and you have the MAC address. This is your MAC address. And this MAC address is unique to your laptop or to your network interface card. Nobody has the same MAC address as you, and you need to be aware of these information. And before that, let's go to the command window and type ipconfig/all. So this also, so you are with me. If you are with me here, you can just edit. Let's make it a little bit. So here, so buffer size large. So here we have this information about our network. So just type ipconfig all. You will be able to find your MAC address as well. The MAC address is called the physical address, and you have DHCP enabled, which assigns the IP automatically for you. And you have the IP routing enabled, all the features here. It's very important before you do anything or this. And you have the Windows adapter, you have the Intel, you have, so the default gateway. So this is your IP address. If there are computers or there are operating systems that don't allow you to see the IP address from the settings. So if you want to see it, you can just type this command on the DOS, or if you are in Linux, there are specific shells, you can use them, and you will find your IP address. This is your IP address, and the subnet mask is this, and then this is the default gateway. What's this default gateway? Anybody knows this? This is basically the IP address of your router. Or now, what's your router? Your router is your access point. So the access point itself inside your home is basically a router, is basically a switch, is basically a modem, is basically an antenna, is basically a firewall. All these things are together, conduct and jointly designed in one device called the access point. Now, for companies, you don't have this thing. You have these. The routing functionalities are separated from the switching functionalities, which is also separated from the firewall functionality, which is also separated from the modem functionality sometimes. But here, for the home devices, all of these, you have them only in one device called the access point. And you have the DNS server, you have the, okay, let's take this IP. This is the IP address of our wireless access point, yes? And let's go here and try to access it. So we have 192.168.1.1. So here, as you can see, I logged in, I connected to my Wi-Fi access point to the router, and this is the IP address, and this is the login. Now there is username and password, you can enter them, but I don't want to now to talk about how to access it and the configuration inside it and this. I want to show you that when you can click here and see that the connection is not secure. What does this mean, that the connection is not secure? This means that you don't have encryption between your browser here and your access point. Why? So in the old days before 5 years, browsers didn't have the functionality to show you that the connection is not secure here. Okay? They didn't show this. All the browsers, they were showing all the websites the same. They didn't distinguish. Here, when you click here, you don't see any security, any encryption technique, any security method, any protocol, anything. It tells you that there is no encryption methods being implemented between you and your access point. What does this mean? This means that the access point cannot generate a public key to send it to me when I want to talk to it. It means that my connection, if I type my username and password here, and let's say that Yazid is in my network and he uses Wireshark, he will be able to sniff my username and password. Okay? If Yazid is within the coverage range of my access point and he entered the username and password, he will be able to sniff my username and password, and I will be in trouble. Why I will be in trouble? Because Yazid, he can use this username and password and log into my access point and change the password responsible for connecting me to the Wi-Fi access point, which is here, the access point, the Wi-Fi, the password you enter before you log into your network. Turk Telecom ZHHRJ. This is the SSID name of my Wi-Fi access point. So if this connection is not secure. Means the data that you enter in your browser will not be encrypted. If someone is within the coverage range of this wireless network and I enter my username and password and he uses Wireshark, he will be able to sniff and see the username and password. He takes those username and password and log in to the IP address of the Wi-Fi access point and get into the Wi-Fi access point and change the password of this network. Then what will happen to me as the owner of the Wi-Fi access point? I will be completely out of my network. It's my access point. It's my internet connection. I'm paying for Turk Telecom money to use it, and I'm not even able to access it. He changed the password. He can do also other stuff that's more dangerous than this. He can let you know that you are okay, securely connected and everything, but he can get your traffic to another point, analyze it, get to know what you are doing, what you are browsing, everything like this. So this is critical. This is serious. So to avoid this, it was also the same with all the websites in the old days. Like let's say if you have, I can show you many websites that are still they have this title called not secure, and the reason for it because they don't use SSL, they don't use TLS, which means they don't use this encryption method, this asymmetric encryption method. Okay, they don't use this encryption method. Okay, now let's just this when I type wikipedia.org, it's just typing an IP address for Wikipedia. So if you go to whois, if you want to know the IP address of Wikipedia, just go to this website whois and just type Wikipedia. You will get so usually now the website is down. I don't know why, but usually you just type the IP, you type the URL of the website, and it gives you back the IP address. So it's basically you have this DNS functionality because it's hard to remember IPs for people. It's easier to remember names. So we write names of websites instead of writing their IPs. But I wanted to show you that you can get the IP address of Wikipedia.org and access Wikipedia by entering numbers here, by entering something like this. Something like this. Just click enter, and this can take you to the web server, can take you to the IP address, to basically the website that you want to connect, which means that each and every website you see with a name, with a URL has an IP, and you can take this IP from a service like this. If you click an IP and you don't get anything, this means that this IP maps to nothing. So going back here, we are talking about the asymmetric encryption, and we want to know where it's used practically. Get back to another website like Antalya, the university website. Here, when you click here, it says that our connection is secure. Your information, for example, password or credit card numbers, is kept private when it's sent to this site. What does this mean? That if you log into your account, everything that you enter in this website will be encrypted. So let's see the certificate here. This is the certificate. The certificate is intended for following purposes: ensures the identity of a remote computer, It proves your identity to a remote computer. And here also, you need to click in, and you can even know who's generating this certificate for this website. It's GoDaddy. Well, and the certificate is valid until this date. So, and now when you go to the details here, you will see that the serial number, you will see the signature algorithm being used, it's RSA. And the public key, this is the public key. This is basically the key that we as users of the website use to send our data to the web server of this website. And if you can see the public key link, the public key length of the RSA algorithm is 2048 bits. And this is the value of it. And you can know the issuer, and it has also signature algorithm. The signature algorithm is used for authentication purposes. And you have the public key parameters. You have so many details here which are related to encryption algorithm. So, which means that this website is relatively, somehow taking into account security standards and the security levels that are acceptable on the internet. This website is somehow secure, let's say. Now, let's go to another website and see if it uses the same encryption method as this. Okay, this uses RSA. Just focus with me. Uses RSA, and I can close this, and I can now go, for example, to researcherstore.com. So let's click here and click on the certificate and see the details here. The issuer is different. Here it's not GoDaddy, Cloudflare, and this. And you have the same thing, signature algorithm. The signature algorithm here is more advanced than the previous one. This signature algorithm is the same as the one used in Bitcoin, in cryptocurrency. It's called ECDSA, Digital Signature Algorithm, Elliptic Curve Digital Signature Algorithm. This is just like the one used in cryptocurrency and the blockchain. Now, what's the public key here? What's the encryption algorithm? It's called ECC 256. Now, I want you to compare which one is more secure. A website that uses ECC algorithm or RSA algorithm. Let's go back to the slides to answer this question. So here in this slide, you can see that ECC encryption algorithm of size 256 has the same security level as the RSA encryption algorithm that has size of 3072 bits. This called elliptic curve cryptography, which is used in Bitcoin and cryptocurrencies, and this RSA that's used in most common websites. So, which means which website is more secure? This using RSA or the second website, because the first website was using 2048. Looks like that the second website, this one, which uses 260, this is the certificate. It uses elliptic curve cryptography with 256 with this digital signature is more secure than the website that uses RSA with key length of 2048. You got the point? This is those two encryption methods that are responsible for securing your data that you put on the websites are the most common ones used on the internet, and called ECC and RSA. ECC has lower key length than the RSA length, but more security than the RSA length. If you want their security to be the same, then if you are using in ECC, if you are using a key length of 256, then RSA, to get the same level of security as ECC, elliptic cryptography, you should use a key length of 3072 bits, which shows you the difference. Now, this RSA is usually used with most of the websites, I mean, for encrypting WhatsApp messages. You see that WhatsApp messages sometimes tells you it's end-to-end encryption and this and that. Usually they use RSA, and ECC encryption is the more advanced version of it, and it's even used in cryptocurrencies and Bitcoin and those things. Now, how ECC works, we understood how RSA works. To remind you one more time, we simply said the following. If I want to send data to the website, the web server here gives me public key. My public key here is this. If I tell you find public key that you use to encrypt your data, you tell me this is the public key. So anything that I enter here on the website, there is an encryption algorithm. This encryption algorithm manipulates my data, password, text, credit card, whatever, with this public key, and it goes to the web server. Okay, the web server has a private key, which is usually longer than even the public key, and has the encryption algorithm of the RSA. When he receives the data with the public key, he just gets this as an input and uses the private key with the encryption algorithm and gets the data back, the original data that you have entered to the website. Okay, this is how it works, as simple as it. Yes.
We cannot see the screen. We can hear you fine.
Okay, no problem. We can show you this practically of how it works exactly one more time. But like we can now tell you, just summarize to you the following, that we have asymmetric encryption and we have symmetric encryption. We have two different cryptography approaches. We have so many cryptography algorithms. Some of them are secure, some of them are more secure, some of them are less secure. At the end of the day, what determines what you need to use is your application and your use case. We talked about asymmetric approaches, the symmetric approaches, the ECC and RSA, and how they compare to each other and how to find them on websites. But most importantly, the differences between ECC and RSA. For now, we can have a break now. We can stop here, and then we can continue in the next, after 10 minutes, so that you can refresh yourself a little bit, maybe drink something, go to pray, and then come back after a few minutes. So I'm going to stop here and see you in the next part.